Hey folks, how's it going? So in this one, we're looking at question number 10, and we're working with the greatest integer function, right? So we have f of x equals the greatest integer function applied to 1 over x. Right? I personally don't like this notation. I think it's too cumbersome. But what it means is whenever you have the greatest integer function with x, it means you want n less than or equal to x, where n is actually an integer, right? So you want the greatest integer that is less than or equal to the argument. Okay, so we have a bunch of questions related to this. Let me take a look. All right, so for part A, what we want is we want f of 3, we want f of 1, and f of 1 over 4, right? So these are, I guess, just to make you comfortable with this function. Okay, so let's start with f of 3. What is that going to be? It's going to be f of 3, that's the greatest integer function of 1 over 3. Right, so what's the greatest integer that is bigger than or equal to this, right? I guess it makes it obvious if you write it in the decimal format, it's going to be 3, 3, so on, right? Okay, so obviously the biggest integer that's less than or equal to this number is just 0, right? We can't go to 1 because that would overshoot, so 0 is the best option. Okay, now similarly, if you look at f of 1, what is that? It's just the greatest integer function of 1 over 1. So that's just the greatest integer function of 1. We just draw a separator like that, which is going to be just 1. Right? So why? Because, again, there's this, it's not a strict inequality. Sorry, a strict less than sign, right? It's less than or equal to. So 1 should work here. So anytime you pass in an integer to this function, right? I'm not saying x, because in this function, we're actually taking the reciprocal, right? But if it were just x inside it, inside these square brackets, then anytime you pass in an integer, it would just be that integer itself. Okay? And the final thing we want to look at is f of 1 by 4. I'm just going to make the most out of this board. So if you look at f of 1 by 4, well, the first thing we want to do is just, it's like a reciprocal of a reciprocal, right? So 1 over 1 by 4, right? So that's just actually 4. And as I just said in this part, anytime it's an integer inside, you get the same integer back, right? Because hopefully this helps you figure out how this function works. I'm going to move on to the next part. Hey folks, all right. So yeah, for part B, what we want to do is you want to look at the limit of this function as x approaches these numbers 1 and 0 from both directions, right? So this would just be the limit as x goes to 1 from the negative direction of 1 over x, right? So think about it this way, right? X is still a positive number, right? So it's actually going to be, if it were equal to 1, right, we would just get 1 inside the parentheses, right? But since it's not equal to 1, we're going to get, the numerator is a little bit smaller. The denominator is a little bit smaller than 1. So as a result, the whole thing is going to be a little bit bigger than 1, right? Because you're dividing by a smaller number, okay? So you could write it as 1 plus delta, right? So, don't panic. What I'm basically using delta as, right? I'm just using it to denote a small positive number, right? But it's much less than 0, right? So again, if x were actually equal to 1, delta would just be 0, right? Because we don't have anything left over. But since x is a little bit less than 1, right? It's not gonna, it's maybe 0.999 something, right? You could look at it like that. So as a result, the numerator is going to be 1 plus some decimal place is something, right? So that extra is what I'm denoting by delta, right? So simply the biggest integer, which is less than or equal to this thing, would just be 1, right? Because we're just a little bit over 1. Okay, I hope that makes sense. I'm going to use the same technique in the other questions. All right, so let's see. We have limit as x goes to 1 from the positive direction this time. It's very similar, isn't it? So it's 1 over x. So, but the sign next to delta is going to be reversed, right? So this is actually 1 minus delta, right? And once again, delta is again, oh, I'm sorry. This should be delta. It should not be less than 0. It should be much less than 1. Yeah, because it's not less than 0. It's still a positive number, but it's just very small, right? Okay, apologize for the confusion. So, yeah, so in this case, you see x is a little bit over 1. So as a result, when you divide 1 by x, the result is a little bit less than 1, right? So that's just going to be 0, right? Because the greatest integer, which is less than or equal to something a little bit less than 1, is just 0. Okay? I hope that makes sense. So right away, I want to note something at this point, which is also just the part C of this question. We see right away that this function is not actually continuous, right? At all real numbers. Because you see, whenever you look at a proper integer, the limit of this function approaching as x approaches that integer from the positive direction is not the same as the limit from the negative direction, right? So for 1, you see it's different, right? Okay, so let's look at 0, right? So we have limit x goes to 0 negative 1 over x, right? So take a look at this. What is it going to be? It's going to be 1. Well, actually, if you look at it right away, it's just undefined, isn't it? Right? Because you're still dividing by 0, but the thing is, it's actually you're dividing by a negative number, right? Something very close to 0, but from the negative direction, which means this whole thing 1 over x, it's going to be negative tending to infinity, right? So I'm just going to write it like this, right? The limit does not exist. Okay, and I don't need to do it uh, in a much more elaborate way for the positive direction. It's going to be the same thing, 1 over x. But the difference is we're still dividing by 0, so it still, explodes. But we're doing it with a very small positive number, right? So it's going to be positive infinity. Okay? So once again, it also is not continuous at f of 0. Yep, that's what we had for this question. That's all. Thank you.